Hi there, welcome back. I'm doing another log transformation here. This one actually has a horizontal shift. So as you can see, because the vertical asymptote is no longer sitting on the y-axis, there's obviously a horizontal shift going on in here. So we've got to look at the horizontal shift, the vertical shift, what base this log has, and whether or not there is a constant in the front. So basically what we've got is we've got y equals a log base b of x plus or minus c, close the bracket, plus or minus some vertical shift up and down d. Right, so how do we approach this? What's the first thing we do? First thing we do is we look for where the vertical asymptote is. The vertical asymptote for this particular function is sitting on x equals minus 2. So that basically means what happens is the axis is actually moved over 2, or the graph is moved left 2 units. So that means that inside the brackets of the log function we'll have an x plus 2. Right, next thing we always look at is from this vertical asymptote here, we look across, and typically it would cross the x-axis at this point here at 0. It would cross that x-axis there 1 unit across. But when we go 1 unit across, it has actually gone 1 up. Okay, so that means that we've got a vertical transformation going on here, and this vertical transformation will be a plus 1. So we've got some constant in the front, log, some base we don't know yet, bracket x plus 2, close the bracket, plus 1. Now what we're actually got to do now is we've got to find out what base this is. So typically again we start at the vertical asymptote and we go across until we hit a y value that has actually got an integer value. Now if we go across 2, we find that we've actually go up to 4. Therefore we've actually got an integer value. Therefore it's starting to seem like the base that we've got here is log base 2. However, what we'll do is we'll check, because if it's log base 2, we will also get one at 4 and we'll get another one at 8. So we'll just check. 1, 2, 3, 4, and we go up, and yes, we do get another integer value. And if we go across 1, 2, 3, 4, that's 4, 5, 6, 7, 8. If we actually went up to here, if I go up to there, put that on there, and go, oh, here we go. We have got another integer value. So this is definitely looking like it is log base 2. So we've almost got everything now. We know that this is log base 2. We've got bracket x plus 2, close bracket, plus 1. We're just waiting now for seeing if there's a number in the front. Right, if it was 2, again we're going to consider this here because everything's moved up 1. If it was log base 2, we would expect it to be up there for 1. We would expect it to be at that point right there. Okay, we'd expect it to be there. Just to let that point away. Right, but it's not. It's not actually up 1. It's actually up 1, 2, 3 times bigger than what we'd expect. So let's have a look at the next one, which is over here. At this point here, which is an annotation, and I'll just move it up to the top there. Right, at that point there, again, now we've got across 1, 2, 3, 4. Okay, so we'd normally expect it at 4, and 4 would normally be 2, up 1, up 2, so we'd expect it to be up 2, but it's actually gone up a lot more than that. So it's actually gone up 1, 2, 3, 4, 5, 6. So it's gone up 3 times more than what we'd have expected. Over here it went up 1, 2, 3 times more than what we expected. We expected when it came from there, goes across 2, up 1 for a normal log 2 function. A normal log 2 function would be across 4, up 2. This one has gone across 2, and then it's actually gone up 1, 2, 3 times bigger than what we expected. And then when we go across 4, it's not gone up 2, it has actually gone up 6, 3 times more than what we expected. Therefore, if we actually hover over it, we're guessing that it's going to be a 3 in the front there. And there it is, it's y equals log 3. Remember that slash 2 means base 2, x plus 2 plus 1. So hopefully you've got a good idea on how to transform logs now. Thank you.